Our next presenter, ladies and gentlemen, is Dr. Sonny Tam. He is the Amristar Group's expert on Open Geospatial Consortium standards. Please welcome Dr. Sonny Tam.
Thanks. I'm going to talk about a model first that I try to structure the discussion around. Computing's all about input, process and output. As far as the diagram of the model that we put up before, we've got this interesting spiral because we can do things with GIS which is low level, and we can do things with GIS which is at a higher or application level. So I'll put a few examples up of things that can be done in the cloud. Now, what are the disadvantages? Well, network bandwidth becomes an issue, and latency is increased. You'll see information in the press about 100 megabits per second to start with, and then up to 1 gigabit per second in the future. However, none of the documentation that's been released so far mentions latency. So, in our model, I've just put thick. We increase the bandwidth so we can move more around and move it around faster. But there is a minimal improvement in latency compared to other technologies that we already have. At first glance, for us in GIS, it's all good. What's the catch, right? Well, speed, right? When you're looking at application performance, how many presentations have you seen at this conference and other recent conferences where you actually do get a live demonstration of something on the cloud? Most presenters, including myself, we're not gutsy enough to do that. We talked about the commoditization of cloud and that it doesn't matter where it is, how it's implemented, virtual, how it scales, and that's all supposed to be transparent to the user, transparent to the application. Unfortunately, it's not that simple. When you commoditize something and when you split it up, your communication links become an issue, and finding where the bottlenecks are is often harder than writing the program from scratch. There is a business and market perspective to commoditizing cloud, and there's also the technical aspect about breaking things up. The speed of light is an ultimate barrier. Computing is faster the closer things are, and that's both in proximity and time, and in quantum physics they're sort of the same thing. At the speed of light, Sydney to Melbourne, which is probably the busiest data route, is about 3.2 milliseconds. That's the ultimate theoretical barrier. It won't get faster than that. I've given an example of Perth to New York. If you're looking at international hosting, international cloud, which could be anywhere at any time, 62.5 milliseconds. 1 millisecond is a very long time. A modern CPU core can do upwards of 3 million operations in 1 millisecond. In fact, it's more than that because it can be doing up to 20 operations at the same time. So think of all those millions of operations that can be done in that millisecond. And then step back and think about storage and communications, which is how we move all of this stuff around. What we're doing is we're making the pipe wider. We can move more bandwidth, but the latency hasn't changed. It's still 0.1 milliseconds. So how does that affect us? Well, practical GIS often suffers from performance bottlenecks like any other high-performance computing application. Now, each application is different, how it uses the data, what it does to it. We've got complex algorithms, we've got lots of data. We're doing the same kind of operation on lots of data or different kinds of operations on the same data? All these things affect how your application is going to run. And once you split things up and take it out of your own computer, things change. Now, if you think about what, say, a modern smartphone can do, and you think about the computing requirements that were around the time of World War II during the cryptography battles, an iPhone would have actually won the war for either side, comprehensively. So I carry 64 gigs or something, 30 to 64 gigs in my pocket. That's significant. And we tend to underplay the fact that, okay, we've got petabytes out there on the cloud now, but we can actually do quite a lot on our own, in our own pocket. Okay, so this constant tension between thick versus thin client. You can do more on the device, but do you want to? We could do it in the cloud. So what lessons have we learned from the past? I mean, we really want to think about how to apply techniques, advanced research techniques and things that have come along from traditional computer architecture to these problems that we're having now. You really need to look at your application requirements. Is it real time? World of Warcraft, first-person shoot-em-ups, they've got a whole different set of requirements in terms of frame rates and the need for fast latency. Whereas if you're doing a batch process simulation for weather modelling, your latency doesn't matter that much because it's so much just processing. There are popular techniques which are proven to hide the latency, and we can adopt those within cloud GIS type applications. And they're basically pipelining, which is a form of multi-threading, doing more than one thing at the same time, sort of like a queue, caching and fragmenting, so breaking up and reordering the way that we do things. But for the purposes of our discussion, NBN, GIS and cloud, we probably can't put everything in the cloud, not all our storage. The latency would kill us. Opening a file, a very small file, would take too long. If you're looking at real-time interactive, so let's say augmented reality, 20 frames per second kind of thing, we can probably forget wireless. But really, if you go out on the NBN, you might as well cross the continent. Is that a bad thing? If leaving your environment means that it's somewhere else in the world and the application can handle that and has been designed to do that, then that's not a bad thing, right? The bandwidth is there, and we can hide the latency to an extent. All those processing and storage resources, and not to mention the services and applications as well, they are very attractive. And the question is, how do we get the data to and from them efficiently? There was a quote from one of my early networking lectures back in when I was an undergrad, that never underestimate the bandwidth of a station wagon full of DVDs. We know that the NBN will make things better, but watch out for latency. So I'm sorry, I can't really answer any questions. It depends. It comes down to your application requirements and thinking about what we do. So you want to keep your fast-changing data that you're using and fiddling with and manipulating closer to you, and put the slower-changing stuff, the big, heavy stuff, which is just there, that can go in the cloud. These are two things that I think we can agree on without too much discussion. And put the processing where it's practical, because although there's a lot of processing resources out there in the cloud, and we've had some statistics from, say, Google, I can do a lot of processing in my pocket, thank you very much. We've got a gigahertz processor in lots of smartphones now. And again, I'll close with the idea of good software, good solution design. Putting more grunts against a bad solution sometimes won't help. And so I'll close there. Thank you.